We are going to cover this numeric types. As we all know that in Python everything is object. Okay, whether it's a built-in or user defined, you define a class, it will means it will create a you will end up creating an object. If you are creating any integer, you will create an object. So just to show that, this is my Python, my terminal. Here let's say I have x equals to 1. Okay, if I check the type, it is a class int. So means everything is class, and whatever we are creating, it will be a object, not like in other languages. Means there we have variable things, means single entity, like integer is a it's, it's a different thing. It's not an object, it's a variable, it's a data type. Okay, so like that everything here is a object. So in numeric types, there are integer, floats, complex number, decimal, fraction, sets, booleans. All these are part of numeric types. Okay. So next thing is in numeric is what is literals? Literals are just any constant number which we use. Like when we are writing 2, 2 is a literal. We cannot access this 2 directly, right? Means if we want to write 2 equals to 3, this will fail because it's a immutable thing. Literals are immutable. You cannot change these literals. Okay, so there are means 1 2 3, 1 2 3 4, anything, it's numeric literals. Then floating literals, one we write 1.23, like that. There are octals, hex, binary things. Okay, in integers there are means there is a slight change in Python 2.x and 3.x, and actually it's a internal their implementation change. As a developer in 3.x, we will not get any advantage or anything. In 2.x, there was two types of integer. One was normal and one was long. So normal was around 32-bit and long had unlimited precision, means any big number you can write, that will go in long. So usually if you are writing any big number, you used to add a small l or capital L after that number. So Python interpret that as a long number. But in 3.x onward, they removed all these things, and there is only one integer. So it will be a long. It will be a long. Means you whether you write add create one, you write one, or you write a big number, it will be it will not differ anything. So it will be always a long integer type. Okay. Then we have multiple two numeric means operators: plus, minus, into, division. This is right shift. Okay, and this is power, ampersand, etc. And there are mathematical functions also: power, absolute, round, integer, hex, bin, and some utility modules we have in Python, which we'll see as we progress. So this is a precedence order of the operators. Means if you have multiple operators in an expression, how these operators will be calculated. So this is the precedence order. You can see, means yield, lambda. This if else, it is an operator. It's not a normal if else, I think. So it's a ternary selection. Okay, or means logical operators, or, and, not, in, not in. These are membership thing, and is not is an object identity test. So these all are operators which we have in Python, and this is the precedence order. You can think of how it will be calculated. Means if you see two or three operators, you can decide using this table that which operator will be calculated first. Okay. Here are some differences in between Python 2.x and 3.x. I will not go in detail for all these points. These are here in this document. I'll share. You can read here. Okay. Means these are good to know things because we are going to use Python 3.x, so we will not encounter 2.7. So, but if you want to know that what is the difference, then you can read these things and you can try. Okay. So if you have mixed operator, that operator precedence it will use parenthesis group sub expression. Means if you have parenthesis around somewhere, means if you have something like x plus y and then you are doing this, so parenthesis will get precedence. Okay. If you have mixed types in an operator, so it will be converted to a upper one. Upper one means if there are int and float, so and you are adding one int and one float, so it will be converted into a float. So if you are doing this, it will be converted into a float. Okay, but this thing happens only in numeric types, not in others. Okay, and you have this int function and float function to convert from int to float or float to int. So like if you have uh, integer x equals to 8 and you want to convert it into float, so you can use this float function, so it will become a float value. And again, if you what you can do is, so what it will do is first x has a integer, so it will first convert it into float, and again we are calling int, so it will give us int as a result. So these functions we have in Python, and these are very handy and very useful one. So this is the basic about operators and all that. And now in means variables are created when you assign a value to a variable. This is a very important line. Suppose if you write x, no, x is already here. Suppose you are writing, you are creating a variable, just you are giving a name and you enter, it will give you error. It will say a is not defined, because until and unless variable is initialized, Python don't give any, don't align any memory to that variable. Okay. If you write x a is equal to 10, then it will have a memory. Okay. So as in other languages like C, C++, Java, where we used to declare a variable first and then we used to use that. So in Python, declaration is not required. Means you cannot declare a variable. Okay. And I will tell you in this session only why we don't declare a variable in Python. Okay. So variables are replaced with their values when used in an expression. Okay. Variables must be assigned before they can be used in expression. Variable refer to object and never declared ahead of time. Okay. So this line, variables are replaced with their values when used in an expression. So for example, if you are using a plus a, so what happens is when we write this expression, interpreter replace the value of a, means it will replace it here a, instead of this a it will replace 10, and it will replace 10 here, and then it will calculate 20. Okay, so this is the meaning of this line, that variables are replaced with their values when used in an expression. Okay, so you don't need to pre-declare in Python, but they must have been assigned at least once before you can use them. This is same what we are saying this, that whenever you are creating any variable in Python, you need to assign that some value. You assign it to 0 or none or anything, but you will have to assign something. Yes, yes, means in Python is called as a dynamic type language. So what dynamic type means is when you are creating any variable, you directly assign, means you need not to worry about the type, so you directly assign something. Okay, so until you are not writing this line b equals to 20, Python will not know what b is. Okay, we'll discuss why this happens. Okay, right, right, right. Okay, okay. So these are formats how we printed something. Means if we want to print a value, so this is one way to see what the value is. But this, by this way we can see only on Python shell. Okay, but in your program, if you want to see check the value or print the value of any variable, so you will have to use print function. So it will give you what the value is. So these are some formatting, like if you have some, let's take this example only. N equals to 1 by 3.0. Okay, so num is this. So if we want to do some formatting thing, so what we can do is dot to, and then I think num percent. Oh, sorry. Okay, so this will do some formatting. It means like precision, how much after decimal you want to see in float. So these kind of things we can do in Python. Okay, and comparison, we can do comparison also, like 1 is less than 2, so it will give you true or false, whatever it will be. Okay, and if we can add multiple comparison operator in a single line like this. So what it will do is this 1 equals to 2, this will return 0 in this case. Oh, no, sorry, 1 equals to 2, this will be false, so it will return false to you here. This is same as if we write 1 equal, sorry. 1 equals to 2 and 2 is less than 3. It will be same like this. Okay, so we can do all these things. So now one very good change is in 2.x and 3.x is between this division thing. In 2.x, it was this division operator, so it was called as a classic division. So what classic division means is uh, it gives you result based on the type of operands. Means I can show you that 2.7 here online. Yeah. Okay. So in this online debugger means this interpreter has 2.7. So if I write print 10 divided by 4, it will print 2. Okay. But the same thing if I do in with Python 3, it will give you a complete float number. Okay. So this is called true division in Python. Okay. In Python 3, sorry. And in Python 2x, it was called classic division. So if suppose instead of 10 divided by 4, any one operand is a float. Now it will return you a float. So it was, I mean, in Python 2.x as a classic division, results were dependent on the type of the operands. But in later in 3.x onwards, it do not depend on the operands. Whatever you pass it, it will give you true division. Okay. And there one more operator is this floor division. Okay. This is same in 2.x and 3.x. What it do is it truncates your fractional remainders down to their floor values. Floor value means whatever the nearest lowest value. So for example, if we do 10 divide floor 4, it will return you 2. What it did is from this, it tried to figure out what is the lowest integer value, nearest lowest integer value. So it is 2. So it will return you 2. Okay. So this is floor division. You can read it out. All these things. Means in 2.x, in 3.x, it regardless of operand, it will return you the true values. These are the examples which I just showed you. So Python also has bit operators like means if you want to create a variable, a binary, if you want to create a binary variable, so what you will do is this will give like this. You can store binary values. You can do binary operations on this also. Okay. And if you want to see what the binary value it calculated, so you can use this build function. integer object is not callable. Okay. Oh, I created variable of this. Okay. So it will, this bin function will show you binary values, whatever, of 4. Okay. So this function we have, like that we have hex and all those things. So these are all in document. We'll go through once we'll actually need those. So we have some numeric tools also, like if we have one power function, so we can get the power of 2 like this. And if we have one absolute function, so if we have any numeric number, that will give you absolute value, min, max, like that. We have all different functions available. Means we have more than these. These are just for example. I just said we have math modules. It will give you lots of other functions like sine, cos, all these geometric functions and lot